Good morning students. Today we will be discussing about identification of recombinants. As we have already discussed in our earlier classes, how are recombinant DNA created? As you know, for creating a recombinant DNA, we have to first isolate the desired DNA. Isolate. Then we have to take up a vector. A vector is taken. The vector is cleaved with restriction enzyme so that we can create a gap to insert the desired DNA. When we insert the desired DNA in the vector, we create a recombinant DNA molecule. So third step would be ligating the isolated DNA as well as the vector to create a recombinant DNA. Now the recombinant DNA is then inserted inside the host cells to propagate the recombinant DNA further. This we have already discussed. So in this class we will be discussing how to identify the host cells which have the recombinant DNA. Okay? The host cells which have the recombinant DNA, they can be identified with the help of selectable markers. Now what are selectable markers? Selectable markers can be antibiotics, resistance gene, this is the first type of selectable marker. The second type of selectable marker can be visual selectable marker, which can be blue-white selection. Third type of selectable marker can be nutritional requirement selectable marker. That is mu2 gene. It can be used. The fourth one could be GFP. That is green fluorescent protein. This gives a fluorescent color, green fluorescent color to the host cells. So first of all, we will be discussing how to isolate or how to identify the recombinants containing the recombinant DNA with the help of antibiotic selective marker. The particular vector that we select for creating the recombinant DNA molecule, it already consists of two types of selectable markers. Suppose we take a vector. This vector consists of two types of genes which gives it resistance to two different types of antibiotics. For example, here we consider ampicillin resistance gene and tetracycline resistance gene. Now suppose we take the desired DNA and insert it inside the vector. For inserting the desired gene inside the vector, we need to have MCS sequence. MCS, as we already know, it is multiple cloning site. Generally, we insert the MCS inside one of the resistance genes. Suppose here in this case, we insert the MCS sequence within the tetracycline gene. When the DNA is inserted, it is inserted in the MCS sequence. So after the DNA gets inserted inside it, what do we get? The ampicillin resistance gene is intact, but the tetracycline resistance gene, since it was carrying MCS inside it, MCS has been cleaved by the restriction enzyme and the desired DNA has been inserted inside it. So when the desired DNA gets inserted inside the tetracycline resistance gene, the tetracycline resistance gene gets disrupted and inactivated. This method is known as insertional inactivation. Since now the gene is not a complete gene and it is not able its product, so it is not able to express itself. This is why it is known as insertional inactivation. This property is used for further identification of recombinants. How do we use it? When we create a recombinant DNA molecule, there are two options. Some vectors might not take up the recombinant DNA or the DNA insert. They might not become recombinant DNA. Some vectors take up recombinant DNA and their tetracycline gene becomes inactivated. So we have two options, out of which we have to select this one. Now, when the recombinant vector is inserted inside the host cells, what are the options that we get? There might be a host cell which does not get transformed at all, so it will not be carrying any vector. There might be a host cell which gets inserted with this one, this vector. So this will be carrying this will be transformed, but it does not carry the recombinant vector. So this one is non-recombinant. Simple vector it carries and it is resistant to both ampicillin and tetracycline antibiotic. The third option that we get is host cells which are inserted with this recombinant vector. So it is a recombinant one which carries a vector which has the DNA insert inside it. That the last one is resistant to ampicillin but not resistant to tetracycline because the gene has been inactivated due to insertional inactivated. So this is not resistant to ampicillin, this is not resistant to tetracycline. This is resistant to both ampicillin and tetracycline. This is resistant to ampicillin but not to tetracycline because of insertional inactivation. Now this forms the basis of separation and identification of the desired host cells carrying the recombinant DNA. How do we isolate the desired host cells? We create Petri plate, an agar Petri plate, and this consists of antibiotic ampicillin. Ampicillin antibiotic. The solution containing the host cells which were transformed by us is poured onto it. So what will happen? The first type of host cell which were not carrying the vector, they will die. Why will they die? Because they were not resistant to ampicillin and they were also not resistant to tetracycline. The second type of host cell which were carrying the vector without the DNA insert, they are resistant to ampicillin and tetracycline, so they will survive. The third type of host cells which were carrying the vector with the desired DNA insert, they are also resistant to ampicillin but not to tetracycline. But here the selection is on the basis of ampicillin. So the type 2 and the type 3 host cells, they survive and they grow. Suppose we get these colonies. Now out of the second type and the third type, we have to select the third type. We are interested in the third type because the third type carries the recombinant DNA molecule. For this, we have to create replica plate. Now we call this as a master plate. We create another Petri plate, agar Petri plate, and we put tetracycline antibiotic into it. Now we take a wooden block, same size as the Petri plate. We mark a point of origin on both the Petri plates as well as the wooden block. Cover the wooden block with a velvet paper. Touch it here to take up the colonies from the master plate. Same position colonies of the master plate to the replica plate. This is now known as replica plate. So, which type of colonies would grow here? We have two types of colonies here, the second and the third. The second one was which was carrying the vector without the DNA insert, and the third one was the host colony which was carrying the vector with the DNA insert. The third one in which the DNA insert was there was insertionally inactivated, so it is not resistant to tetracycline, but the second one was resistant to tetracycline. So the second colony will grow here. Suppose we get some colonies here which are in this position. Now the question is, we are interested in the third type of colonies, and here we are getting the second type of colonies. So where have the third type of colonies gone, and how can we identify and pick them up? How can we use them further? We compare these two plates, mark which colonies are there. Suppose we see this colony is there, we see this colony is there, again this one is there, and this one is there. So this means these are the colonies which are the second type of colonies carrying the vector which does not contain the desired DNA insert. Remaining colonies which could not survive on tetracycline plate are the ones which were carrying the recombinant DNA. So we will be isolating these colonies, and these can be used further for the propagation of desired